Dear students, welcome back to our I/O course. Before I start with the lecture, I just would like to ask you to go to the stud IP to our intranet, and so that's what you see here, to the I/O course description and so on, and just go to the bottom of this page where you find here a very strange abbreviation with evaluations here, and please just fill out these forms and evaluate the course. Unfortunately, we only noticed that there's recently that there would be a form where you can evaluate 2 lectures, which is Max and me, but just use the free text fields to write detailed information about our courses. What is particularly interesting to us is how you consider or evaluate the digital way we or how we proceed with this online teaching. Okay, so it would be great if you were to fill this form out if you didn't already. Several did already. Thanks. Dear students, welcome back to our final lecture in the course of Industrial Organization. As I told you last week, we will skip this part on research and development. This is in much more detail dealt with in Economics of Innovation, which you already can find on our YouTube channel, Economics to Go. And what I usually did here in this part was a condensed version of the first 2 lectures, and you just might look into that. What I want to do today is just finish this part on advertising, and actually, of course, hopefully, or probably you even noticed, in a sense, the most important event in terms of advertising we had on last Sunday, because we had the Super Bowl, and I just want to give you a few data here from the Economist news magazine. And here you see that there is a tremendous advertising going on in the Super Bowl. The cost per 30 seconds, I don't know whether, I think you can see my mouse, is currently at about 5.5 million. So what you see later in this article, it's mentioned that they have about 45 minutes of advertising time during the Super Bowl, and this makes about 450 million in terms of revenue. What is probably more interesting even for us, of course it's interesting because it tells you about the relevance of that. What is more interesting perhaps with respect to our discussion of the relation between advertising and competition is how these different, or what the advertising expenditures of these different sectors are. Like automotive, you see they really invest a lot, and it's even increasing. And here you might see that currently, in a sense, competition is increasing because they all fight, all these traditional car manufacturers fight to somehow get their new electrical car models into the market. And that perhaps gives them a strong incentive to run a lot of advertising. What is particularly interesting perhaps is telecoms, which advertised a lot last year and also in 2018, but reduced advertisements in 2020 already. And that was the time, I think it was not really even consummated at that time, but it was rather clear that T-Mobile would be able to take over Sprint, and therefore we got a reduction, I think, of 4 to 3 nationwide mobile telephony providers in the US. So it would be certainly a very interesting topic for an empirical study to examine in more detail this relation between advertising and competition and concentration, and perhaps even the Super Bowl could act here as an interesting case study or as a database in a sense. Okay, that's about what I wanted to tell you. What is probably most interesting with respect to what we are going to do today is the question whether these advertising is more or less what we call persuasive. Do consumers want to, do firms want to convince with their ads consumers that they really sell a high value product, so that consumers get the impression that the quality of these products is really high and their willingness to pay increases, or is it pretty much a lot of information? And what I want to do is going back to what we did. Oh, I jumped to the wrong kind of port here. Going back to where we ended last week, I think we discussed this distinction between building value, which is closely related to this idea of the persuasive character of advertising, and extending reach, which has got more to do with the information part. And of course, it's very interesting to find out whether we can empirically test whether a certain advertisement is informative, or whether it's in the first place in order to build prestige, to build value, and so on, or it's more like persuasive. And I want to present you a very nice example of an empirical study. It's Dan Ackerberg's paper published in the Rand in 2001, and you see yogurt is really heavily advertised, both, and heavily studied product. He looks at the impact of TV ads that accompanied the introduction of a new low-fat yogurt produced by Yoplait in already 30 years ago, but anyway, it's interesting. And the question Eckerberg addressed was whether this advertising is really primarily informative, or worked by appealing to the status consciousness, so you feel very well if you eat this low-fat yogurt because it makes you convinced that you are an admirable person, slender, and so on. I don't need to go into details here. The point is, can we find that out? And in order to find that out, of course, you need data. And I don't know whether Eckerberg was lucky, or that he just worked so hard to find this data. Anyway, he found data from AC Nielsen, which is a market research company. And they collected information about 200 households in 2 US cities, in Sioux Falls, South Dakota, and Springfield, Missouri. And they got the information on whether these households watched TVs which accompanied the introduction of this Yoplait yogurt in these cities, or more or less in the US at that time. But what he got was data on whether these households watched or were subject to ads. And then he also has scanner data whether these households really went then to the supermarket and whether they bought this yogurt, and how many ads were observed before going to the supermarket. And these Nielsen data cover 12 months, starting with the 3 months after the introduction of this Yoplait yogurt. And the information Eckerberg got that was whether these households observed these commercials, okay, and whether they purchased this yogurt. And so the point is, and what is very interesting, or his very interesting identification strategy, is whether he could distinguish between whether these users or whether these consumers were first-time buyers of this yogurt, or whether they were repeat buyers, whether they already previously had bought this product, and how many ads they have seen. And so what he did is, that's just a description of how you typically set up such an empirical study for each town or market. So there are two. Ackerberg creates two time series from the data covering these specific market days over this 12-month period. One series is with the number of first-time purchasers as a fraction of number of shopping trips, and the other is the number of repeat purchases, okay, as a fraction of the number of shopping days. And of course, he also has additional controls, like the price of obviously is a very important variable in terms of the decision whether to buy the yogurt. And also, of course, what is of main interest to us is the number of advertisements, the number of commercials to which the buyers have been exposed. And so what he did is he always started with the simplest thing, and that would be an ordinary least square regression. And he distinguished clearly between the first-time purchases and repeat purchases. And he asked, how do first-time purchases depend on the price, on the number of advertisements you observed, and on the market in which you're in, and the same thing for repeat purchases. And market is just a so-called dummy variable, 0-1 variable, where you just set a 1 for Springfield and the other for the 0 for the Sioux Falls. And the point here, and this is really how he identifies whether advertisement is mainly information, is that if it's mainly information about the existence of a product, it's clear people who already who have bought these yogurt previously, they are informed about the yogurt. They know about the existence, and therefore additional advertisements should have hardly an effect on these repeat purchases, but it should have a much larger effect on these first-time purchases. Okay, and in technical terms, that means this coefficient A2 should be larger than B2. Okay, and that's what we are looking into just right now. And so our results are, and that's some kind of typical regression output. Typically, you also have the number of observations. You would have some R square and some further tests, but the interesting parts for us, for our purposes, are here. And what is interesting here is, of course, what do we find for the first purchases and what do we find for the repeat purchases. For the first-time purchases, we find that here this coefficient of minus 0.038. Here you see the standard error, and the rule of thumb is that if the standard or 2 times the standard error is smaller than this here, you get a significant result, because here this is nothing else, this 0.038 is nothing else than the expectation. And you know, in the interval with 2 standard deviations around that, there are about 95% of the observations, or actually it's the other way around, only 5% of the observations are outside this interval here. So with a 5% significance level, we get a significant deviation from we can say that price is significant or has a significant effect on these purchases. So, and this is that's a nice result as expected, because we see this has a negative sign. If the price is higher, people will purchase fewer yogurt or less yogurt, and that holds both for first-time purchases as well as for repeat purchases. Again, we get a significant result here. In terms of the next point, we might look into markets, and here you see the dummy variable is also significant. That just means that obviously people in Sioux Falls or Springfield was the one, I think here, like plate yogurt more than the people in Sioux Falls. But the interesting coefficients are these two. These would be called A2 above, and this would be the B2 coefficient. And here you see these A2 coefficient is significantly positive. What does this mean? Ads do have a significantly positive effect on purchases of your plate yogurt for first-time purchases. And the interesting thing, even if we get a positive effect as well for repeat purchases, the first thing is that the order of magnitude is only half as high as here, as you see. And the point is, this is not even significant. We cannot say that it's significantly different from zero, and that advertisement have an effect on repeat purchases. And now this is an important result, because this tells us, and this is just what's stated here, this last finding, and that's here just the points I just explained to you. This last finding is the important one. It confirms the view that advertising is mostly informative. It works by extending the reach, in a sense, by getting more people informed and convince them to try this new product. And so this information about the product's existence and its primary characteristic, it's a low-fat yogurt and so on, really convince people to buy this product or to test this product. Okay, so hopefully this was clear, and it's really ingenious, this approach here, I think, and that's why this paper got published in the end. And so the important point is here, much higher effect of advertisement on first-time purchases than on repeat purchases. So not that these people felt very well after they observe the ad and then thought, oh, I really have to buy your plate again, but it was basically information. So there are some further technical details here. We probably would better use some kind of discrete choice model, because such a purchase is a binary 0-1 decision, and ordinary least square, if you take the courses from Professor Winker, he will tell you that ordinary least square is not the best estimation technique. In this case, you better should use something like the probit or the logit. But even if you do all these more advanced and sophisticated kind of analysis, even if you allow for other factors, such as the price of rival yogurts, you still, or Eckerberg still finds that the basic results extend to these cases as well. Advertising has by far its biggest and most statistically significant effect on first-time buyers. So it's really information. And that's the interesting thing. And I think somewhere in the notes, I refer you also to a very recent paper by Elizabeth Honka, Ali Hotashu, and Maria Vittorino. And it's also published in the RAND in 2017. It's about advertising in the US banking industry. And these authors find that advertising mainly or primarily is a shifter of awareness and not of consideration or choice, not of preferences, but they just give information, and advertising makes consumers aware of more options, and they search more and they find better alternatives. And as a consequence, the market share of smaller banks increases and the industry becomes more competitive. So here you get a rather positive picture of advertising. Okay, so that's about what I wanted to tell you here on advertising. Actually, you will see once we move on to this part, chapter L, this is just some more, in a sense, technical details and more explicit models of asymmetric information, which just take up a kind of discussion we already had here. So we still keep on discussing this topic. And before I move on, I just want here make a short break and ask for questions in Webex. Okay, after we finish this part on advertising, so we distinguish between persuasive advertising, informative advertising, and we saw at least partially advertising provides important information. We also saw, this was this nice paper by Simon Anderson and Regis Renault, that it might be even good to not provide too much information in such an advertisement, because otherwise the market might break down. Somewhere in the notes I also give you a link to a recent paper on false advertising, where companies make false statements in their advertisements, and still what these authors show is that this might be a good idea, in particular if it's done. Of course, a false advertisement you would do if you are of a low quality, and if you make claims which are then not warranted. And what they say is that if there is competition, these kind of false advertisement serves to reduce or constrain the market power of high quality products. Okay, actually, this is already a preview of some of the topics we discuss in this part on asymmetric information and about product quality, where advertising also will enter the picture. As I told you, we won't discuss research and development, and I ask you to visit our YouTube channel and look at the first and perhaps also even the second part of the course of economics of innovation. Okay, asymmetric information about product quality, which is actually what we did right now when we considered the Nelson good, in which we considered burning money. Okay, and we just want to go into a little bit more detail here, based on what Paul Belflam and Martin Peitz wrote in there, or write in their industrial organization textbook, which is a bit more advanced, at least, than the undergraduate textbook of Pepper, Richard Norman, even slightly more advanced than the quantitative analysis text. But anyway, I just want to give you some more information economics models here. Okay, so what the problem is, until now, we pretty much, apart from the advertising part, we assume that in these models of vertical product differentiation, that product quality is known, or if the monopolist produces different qualities, these qualities is known. But the point is that, and that's what I already introduced in the previous chapter, but for several products and services, you can only be sure about the quality upon consumption. These are so-called experience goods. Remember, we also discussed search goods, and we, as a third category, we discussed credence goods, where you never are really sure whether you got a good treatment or not, in particular from a medical doctor, from a lawyer, or from your mechanic. Okay, the problem here is always asymmetric information. And that just means that consumers have less information than the producers about product quality. And firms produce something, and consumers do not know whether the products they produce are actually of high quality. Okay, so they don't know the quality. And we distinguish here between two different cases. One in which the firm just hides information. The firm doesn't have a possibility to influence the quality of its product, but it can just hide information or provide information where it's high or low quality. Or the firm can deliberately choose its quality, but the consumers cannot observe this choice, and firms might choose a high or low quality. That's so-called hidden action, and related to what is called moral hazard. Those of you who took the economics of regulation course, you see very similar problems where, when we discuss the question whether, in terms of hidden information, whether the firm is of high or low cost, and as a high or low cost, the regulated firm is a high or low cost firm, and then can hide what its type really is. And that's very similar what we are going to look into right now. Here, Paul and Martin are with our have a strong emphasis on pedagogical tools. So they always state learning objectives and questions. So you should become familiar with asymmetric information problems in the product market here. And the question is, how do firms choose quality in the presence of these asymmetric information problems? And then, given we have this asymmetric information problem, the question is, how do pricing and advertising strategies look like? So here the focus will be on pricing strategies. We already have discussed these advertising strategies at some length in a previous chapter. And finally, we already discussed this signaling that was simply our burning money, and we will see what kind of application we can look into here. We start with the adverse selection problem, and this here is really a version of the famous Akerlof model of lemons here with the hidden information. So we have a single seller. Actually, we might have several sellers, but you as a buyer are only matched with a certain seller. So it's the same as if we were to look into a monopoly seller, and this seller has a product, and you don't know what this, for instance, a used car, and you don't know what the quality of this car is. The quality can be either low or high. And the seller actually, so the used car probably would be zero cost, so it's better to think in terms of produced good. And what we assume here is that the production costs are higher for a high quality than for a low quality. We have a unit mass of buyers, and each buyer is the same, or they are all homogeneous, so they have some valuation, some maximum willingness to pay, some reservation price RS, and all consumers prefer the high quality to the low quality. And we assume here that in a sense, we have really two markets. That is, even the low quality would, under full information, be bought, because the willingness to pay for the high quality is higher than the high cost, the high production cost, and the production cost of the high quality, and the willingness to pay for the low quality product is higher than the production cost of the low quality. That's different from the, if you remember from last week, from the situation in which in the Nelson model, where we assumed that our consumers would not buy the low quality. And if there is full information, that's exactly what I told you. The seller can profitably sell the product to buyers, whatever the actual quality is. And here the problem is, with this hidden information, only the seller observes its product quality. Okay, I will get back to this example later on. From the new electrical car of Volkswagen. Do you know whether this ID3, this new electrical model, is a good one or a bad one? I don't know, okay? And you probably should or have to trust Volkswagen if you really believe it's a high quality, okay? And perhaps the alternative might be just that you assign a certain probability, lambda, that the product is of high quality, okay? And then your expected probability, if you buy such a car, is just lambda, maybe 50% that you get, that's a high quality, then you would get RH, plus the converse probability 1 minus lambda, that would be then also 50%, that it's a low quality. Provided we are in a situation in which you know both sellers would sell. You will see below that under certain circumstances, a seller of a high quality would not have an incentive to sell the product. Okay, what we are looking into right now is a so-called three-stage game. In the first stage, nature draws the seller's product quality from some known distribution. Okay, and this known distribution is really this lambda here. And the realization is observed by the seller, but not by buyers. So Volkswagen develops this car, this ID3 model. Whether it's good or bad, we don't know. It might be good, it might be bad, and we just assign a certain probability lambda on that it's good. In a second stage, the seller decides whether to sell at all and whether and which price to charge. And in the third stage, consumers form beliefs about the firm's product quality and then decide whether to buy or not. Okay, so the setup hopefully is clear, and of course, what is clear, if there were perfect information, if it were a high quality seller, the seller would charge RH. If it were a low quality seller, it would charge RL. So now, what the seller, if she decides to sell, can charge is the consumers do not have any further information apart from this probability lambda and their willingness to pay. So we assume here just for simplicity that they are risk neutral. So they are just willing to pay lambda, the expected value of the car they get, and this would be lambda RH plus 1 minus lambda RL, and that would exactly be the price the firm charges. Okay, because if the price is higher, we wouldn't buy, and if and you would not have an incentive to charge a lower price. And we will discuss that in more detail later. The point here is this would then be a so-called pooling equilibrium, because of course both, if the firm is a high type, it would charge this price because of course every seller would tell, of course Volkswagen tells you that it's a high quality car, this ID3, but given that you don't have this information, you just assign as a customer this probability, and the maximum willingness to pay you have is then this price. But if then really both firms are active, it's no problem, because in any case you buy. The point is, under what circumstance will the high quality be active? Only if this P here, the price, is higher than CH, its cost. Okay? If the cost of these ID3 are 25,000 and you these expected valuation is 26,000, you will sell it. Okay, but if this price is lower, the high quality firm could not recover its opportunity cost and would not participate. Okay, but consumers of course would realize that the high quality seller at this price does not have an incentive to participate. Then of course the only rational and fulfilled belief would be that there is no high quality firm in the market, and therefore they will no longer be willing to pay this P, but rather they will only be willing to accept a price equal to the low valuation, RL. And the high quality seller does not post a price, and of course the low quality seller, knowing that rational consumers will expect that there's no high quality consumer, high quality producer active, they have no chance rather than to pay or to charge this price equal to RL. And the important result here, and that really goes back to Akerlof here, is that under adverse selection, you get a situation in which only the low quality survives, high quality sellers exit the market. And of course, this is an inefficiency. Okay, that's our problem. And on the next slide, I just tell you in more detail under what circumstances which equilibrium arises depending on the parameters. Just assume for simplicity some values RL equal, oops, I could just easier write that here, is equal to 5,000, RH, just assume RH is equal to 10,000, and suppose lambda is equal to 0.5, then this price here, this is, remember above, this is just the expected value. If both firms are active in a market, this would be just 7,500. Okay, now what does the equilibrium look like? Depending on the cost of the high quality. And of course, we assume that the low quality will always be offered and that the CL is smaller than RL. Now, we just might draw here a 45-degree line, which should be something like this here. So this would be 45 degrees, because here we have RL and here we also have RL. Now, what you see here already, if CH is smaller than our 7,500, then our firm, our high quality producer, would also be active if in the case of asymmetric information. So here we get this being an equilibrium that the price is equal to 7,500, and we don't have an adverse selection problem in a sense that the high quality is not offered. If this CH, the high quality's cost, is sufficiently low, we will get an equilibrium in which consumers charge or in which firms charge a price of 7,500 and consumers buy, and both qualities are offered. Okay, that's our first case. That was this case here. We get a pooling equilibrium, but in a sense it's not a problem because the firms are active and consumers just in expectation, they just break even because they have to pay their reservation price anyway. Okay, but what happens if CH here is higher than this? Yeah, if it's higher than this, you already know from the above discussion that the consumers are not willing to pay more than this here. Of course, here are not willing to pay more than 7,500. Say the costs are 8,000, and therefore the high quality producer is not active in a market, even though it's that I could draw here, even though it's it could be active up to here in the full information, because it could be active if its margin, its production costs are as high as 10,000. Okay, so here for this part there is no longer this equilibrium, and we somehow jump down so we get this equilibrium here. Or perhaps I should use a different color here, just a text marker. So for these kind of very low costs of the high type, we get this equilibrium in which both types are active in a market. So both, even if you turn out to be a high quality type, you're active and you sell at a price of 7,500. For this part, if your costs are higher, only the equilibrium exists in which only the low type is active, and the low type then charges this 5,000. Now, what is interesting, however, is this other part here. There exists a part in which a low price equilibrium also in cases in which the high type does not is not active in a market, even though he could or she could survive at this price of 7,500. This is just in a sense a situation of a self-fulfilling prophecy. If all consumers think that there is only a low type firm in the market, then the price, and therefore they would only accept a price of 5,000. But if they accept only a price of 5,000 because they think there's only low type in the market, the price will actually be, and I try to work here with more colors, will exactly be this here. Oh, will be this here? Okay, and here there is no deviation from this equilibrium, because they expect consumers expect there's only a low type. The low type charges 5,000 and the high type does not have a possibility to somehow destroy this equilibrium. This changes only here in this situation if CH is smaller than this 5,000. Then it's no longer rational to assume that only low quality firms are active, because if, say, the cost of the high type are 4,500, the high type would be active also at a price of 5,000. But given that firms or consumers know that, then they know it's rational to expect that these high type firms are active, and of course we would jump up right again to our original equilibrium. So here you see, and now it's getting really crowded in terms of my curves and so on. Here you see for a certain part of here you have in a sense multiple equilibrium, because both here a low price is an equilibrium with confirmed or fulfilled beliefs. So this would be a perfect Bayesian equilibrium, and a high price as well. Okay, hopefully this became clear. Otherwise, you just ask then in WebEx. Okay, so but what we see here is that first of all, we get this inefficiency in markets in which product quality is exogenous but unobservable. High quality products may not be offered for sale. And that's the result of Akerlof in his paper. If we have a continuum of qualities, we might see a complete unraveling of the market, meaning that only the lowest quality survives in a market, all higher qualities are no longer offered. So this was adverse selection. What we saw is that, or what we now want to consider, different color. What we now want to consider the situation in which firms can reveal their true quality publicly and costlessly. Okay, do they have an incentive to reveal their true quality? You might think, of course, the high quality firm certainly has an incentive. The point is here, what about the low quality? Okay, because then everyone knows that or all consumers know now that you have a low quality, and then you can charge only a low price, only the 5,000, no longer the 7,500. Okay, but the point is, what is obvious, particular in this case, in which CH is too high. Okay, in which only is higher than in our example 7,500, but lower than 10,000. This is an interesting case because that's a case where the inefficiency arises. In this case, of course, our high quality firm has an incentive to reveal its type, otherwise it has a profit of 0. Now, what about the low type? Now, the point is, again, consumers know that if the firm does not reveal its type, it will be a low quality firm. So it doesn't matter whether the low quality firm reveals its type or not. Consumers know that it's a low quality firm. So it's indifferent between revealing and not revealing. So we always assume that it reveals. Okay? So it doesn't have an incentive to withhold information. And our asymmetric problem is solved. We do not any longer have this unraveling result. Of course, the question is here whether such a device exists where you really can truthfully reveal the type and can do this publicly. Okay, probably an advertisement is not the real thing here, but you might just open up your factory and just allow some auditors to control or to examine your product. Okay. That was the hidden information part, and which typically gives rise to asymmetric information problems, or adverse selection problems. The other part, or the other famous part, is the hidden action part, in which we run into moral hazard. And we have the setup as in the previous slides. Only in the first stage, where in the previous slides, remember, nature chose the type of the firm or the type of the product, whether it's a high quality or a low quality. Here, the firm itself chooses its quality. It can determine whether it has a high quality or a low quality, or it produces a high quality or a low quality. And then in the second stage, again, it sets a price, and buyers form belief in a third stage and about the quality and make the purchasing decision. And first of all, we need to know what the costs are. And if we look into the benchmark of full information and make a certain assumption, we just assume, again, we would assume that the RH is higher than RL, and we would assume that the high quality is more costly to produce than the low quality. Then if the profit gain from the high quality is higher than the profit gain from the low quality, the firm would choose the high quality, and that's just the first best allocation, because the social surplus from this quality, from the high quality, is higher. Okay, and that's of course the interesting question. If the quality choice is a hidden action, the problem, what is the problem? Actually, then as a firm, you obviously see that CL is smaller than CH. So the best thing, of course, if you really can cheat the consumers, you would tell the consumers you're of high quality, but you actually produce a low quality, and that gives you a higher profit. That's the incentive to cheat, in a sense. And the problem is, of course, we have rather rational consumers. They will just know that firms have this incentive. And the problem is here, if we have this asymmetric information problem, it's hard to convince consumers that the product is of high quality, because due to this hidden action, you have this moral hazard problem, as I just described it. Okay, and what we have here is a moral hazard problem in these markets, and firms tend to provide too low quality from a social point of view. And the problem is here, this problem can also not be solved here in this situation. So because the only variable you have here available in this setup is the price. Okay, no information disclosure device and so on. The only variable is the price, and of course, if you charge a low price, you don't have an incentive to produce a high quality. If you charge a high price, consumers will nevertheless believe you produce a low quality, because you have this incentive to produce a low quality. So you really have this moral hazard problem, which you cannot solve here. In economics of innovation, we just discuss such a moral hazard problems in more detail, and look into that in terms of incentives to really provide effort. But if you're interested in that, just attend the course. We move on now to another, or put it differently, we ask now the question whether there's a way to overcome these adverse selection problems by other means than what we just saw in terms of this revelation of the true type of the product, of the true quality, because that will very often be very hard to achieve. What we look into right now, next, is what is called risky investment in quality. So, and the point is that this risky the investment is observable to consumers, and so again, let me take this example of these German car producers, and in particular the Volkswagen ID.3, this new electric car. What you know as a consumer is that the quality level of this car will very much depend on the kind of development investments Volkswagen makes. okay? And the idea is here, the more you invest in research and development, the higher is the probability that the car is actually of high quality. And the point is, that's what you always can observe. You can observe as a consumer how much Volkswagen invests in product development. That's what they have to state as a public company with shareholders and so on. You can read that from the balance and profit and loss statement. That's what you can observe. It's much harder to observe the quality of the car. Okay, so the point is here, our consumers observe the investment level, and they have a clear understanding of the relationship between investment spending and expected quality. That is this lambda. So the point is, if you invest more, the chance that it's really a high quality product is higher. And so we just make some assumption on the functional form of this relationship between investment and the probability of the quality. The higher quality you want to have, the higher investment is necessary. That's what Paul and Martin do. They just assume a specific functional form. So the higher the probability you want to have, the higher is the investment, and investment needs increase more than proportionally, namely in square terms with the lambda. And again, we assume, in order to make the problem interesting after all, that both products are viable. Okay, so it might be I don't know whether this is a good example, but in terms of our ID3, RH might be 30 and CH might be something like 25,000, and RL might be 20,000, and this CL might be 19,000. Okay, both would be profitable, but of course it would be better to have the high quality in terms of the firm. And the full information, so the low and the high quality are put on the market, okay, at the price RL and RH respectively. And of course, again, as you can influence the probability with which you get a high quality, you just maximize as a firm the expected profit. You choose lambda, and lambda, or what you maximize is just here the expected profit. So this is your gain. If it turns with probability lambda, suppose you have 60%, you get this markup, your profit gain or profit margin from the high product, for high quality product, and with the converse probability of 1 minus lambda here, then 40%, you will get this low margin. In a previous example, either the 5,000 or the 1,000 here. Given our example, minus, of course, the fixed investment costs you have. And this is straightforward. You just take the derivative with respect to lambda, and you see what you're left with is just this difference between this gain here, RH minus RL minus CL here. So this is the increase. If you increase marginally the probability, you get the higher margin from the high quality product than from the low quality product. And of course, on the other side, this has to be equal to the marginal cost of an increase in probability. And if you solve then for this probability, that's what we need for later purposes in order to explain that with the situation and the asymmetric information, you just get this. So here again, you see this difference in the gain from the high quality compared to the low quality, divided here by K, which is this parameter which determines the cost or the investment cost. Okay, and now we go back to the asymmetric information problem. Now we observe the firm's investment, I, but not the realization of the quality. Okay, and again, Martin and Paul start with in a sense, the less interesting part. So if we expect both qualities are put on the market, then again, expected utility would be just this here, okay? Same as in a previous case. With probability lambda, you get RH, and you get a high quality, so your willingness to pay is RH. With probability 1 minus lambda, you get a low quality, your willingness to pay is RL, and so you get the price here. This would be the price. If that's a price you can achieve, you just substitute that into your expected profit with probability lambda. You get this price, which is actually the same. So this would be equal to our price. This would also be equal to our price. As consumers cannot distinguish between the two qualities, you get the same price, irrespective of whether you really end up with a high quality and a low quality, and then again minus the cost. But that's exactly the same objective function of the firm as in the previous case. And of course, the solution to this problem would be lambda. Lambda adverse information is the same as this lambda f. The problem, however, is, and the interesting case, and that's exactly what we have here, is when we are really in this case, probably I should jump back. So what we considered here was actually now this case in which CH is smaller than this 7,500. Okay. This is not such an interesting case, as I already explained to you, because we don't have a market failure in the sense that the high quality is not sold, okay? Because the costs are low enough that even if they are only paid the expected value of both the high and the low quality, they still are active. So the interesting case is a different one in which you would not expect that this price that the high quality firm is interested to offer the high quality. So given that, however, given that the high quality does not have an incentive to do that, of course you would not come up with this solution. If you know anyway that the price consumers are willing to charge given this investment level you end up with is lower because they expect you is lower than your costs are, you will not be active. And of course consumers will realize that. And of course they will then, if you have this investment level, lambda f, they will expect that you are low quality. So actually then what you would do is not investing at all. So this lambda A cannot be, and therefore the related investment level cannot be the profit maximizing investment decision. So what you need to do is to invest at least such an investment level so that this turns positive here. Okay, previously, it's hard to come up with a nice example here. In a previous case, we had 7,500. Oh, probably I should go back here and try whether I can do that here. And suppose your costs are something like 8,000. Then, of course, once you say, okay, I think 60% should work. If you choose a lambda of 60%, you get 6,000 plus 40% of 5,000 would be probably 2,000, would be 8,000. And suppose here you choose 61% or 65%, then even this price here, the expected value would be so that you are willing to provide this service. So, and what you get here, of course, is that then this lambda is just solves this equation here with equality. Okay, that's what you get. And this here, of course, must be higher than what we previously had. And so what we see is that this adverse selection effect makes the full information investment level unsustainable and may lead to overinvestment compared to full information. May lead because, of course, you also can have a lower level of CH, and then this problem does not arise. Okay, so that should be hopefully clear. I don't know whether we have an example on that, probably not, but anyway, so I think it should be rather, an example in the problem sets, but it should be rather straightforward because these are straightforward calculations. So the problem is here, or if the consumer observes investment in the reliability of the products, but not reliability itself, a firm may actually overinvest in reliability compared to the and quality compared to the full information level. Okay, and so the high quality firm will only be active in the market, will only participate if the consumers can be convinced that the high quality outcome is more likely than the low quality outcome. Okay, that's was again rather complicated, so I make another break here and ask for questions. Okay, we are still working on methods on how to solve this asymmetric information problem. And now we get back to what we did in a previous chapter on advertising and ask how advertising, or in particular price signals, might act to solve this asymmetric information problem. So the starting point is the one we already had in the previous chapter, that advertising works as a signal, and at least that's part of the story here. Firms spend large amount of resources of advertising and other marketing activities without a lack of an apparent message, and the point is, or at least the positive view is, that this is just money spent to convince consumers that the product is of high quality. And what I already did here was the presentation of what is called this Nelson model with the repeat purchases of these experience products. And you saw that here firms can use advertising to signal the quality of its product by burning money, because consumers can derive from or infer from this situation that it must be a high quality, because only if you have offer a high quality, it's clear that consumers would be willing to return to you and to purchase this product again, to have dinner once again in your restaurant. And I skipped this part on the repeat purchases because we did that already. You can go through this part. It's put here more in terms of the Milgram-Roberts model. What I want to do here is to look in this situation in which, or these two other channels, the first one in which where we have different consumers. We have informed consumers and uninformed consumers, and we can hear that works only with pricing, as you will see, and you can see how how that works in this situation. And the second thing is if you have cost differences depending on qualities. Okay, so I now jump to the price signals when consumers are differently informed or have different information. So again, we now do not use this kind of experience goods setup in which we have multiple periods, but we have just a single period, and we have some share lambda of fully informed consumers, say 15% or 30% of all consumers are informed. That is, they know whether these ID3s have a high quality or low quality. And what I'm going to show to you is that if this share is sufficiently large, a firm can separate, or actually that's rather straightforward, a firm can separate even with full information prices. If the share is smaller, the firm has to lower its price below the full information level, and informed consumers will generate an information spillover. So uninformed consumers obtain information through the firm's price because they know that some other consumers have better information and act according to this information. So given the fact that these high quality, or these informed consumers will buy the high quality product, firms or consumers can infer from that that it's a high quality. And I'm going to look into that in more detail right now. So, and all of you who did economics of regulation, actually that's what we also did in our section on price discrimination, is we have to look into the incentive compatibility constraint, okay? Now, we have incentive compatibility constraint of the low type, and how does that look like? Of course, the low type has to truthfully reveal its type, and that's done by setting some price RL and some price RL, which is equal to the willingness to pay, and the profit from setting this price truthfully is just RL minus C per consumer. And this profit from revealing truthfully must be higher than from cheating, that is from claiming to be of high quality. And now if the other firm charges some price PH, of course the profit would be PH, or yeah, if it were to cheat, if it charges a price PH, its profit per unit sold would be PH minus C. But of course, here, if it only can sell to people who are uninformed, okay? It can only sell to people who are uninformed then. And so we just assume here as a tie-breaking rule that they then would buy from this firm here, from the low quality firm. And now you see immediately, if everyone is informed, okay, if everyone is informed, that's this exogenous share is really very important. If everyone is informed, lambda would be 1, and of course that would be then 0. Okay, so it does not have an incentive to cheat. So that was what we had on the previous slide. With a sufficiently large share, firms can separate with full information prices. So and what you always can do, of course, is now calculate here PH would then be RH in the full information outcome. It's straightforwardly to calculate the share lambda, which is sufficient in terms of informed consumers, so that we only the separating equilibrium in which the low type truthfully reveals its type to consumers and charges price RL is the only equilibrium. Okay, but of course, obviously, if lambda is 0, just look at the other extreme. Given that PH is equal to RH in the full information outcome, the firm has always an incentive to cheat. Okay, and now what we have to do in order to, or not we, but the high type has to do in terms of the price it can charge is it charges a price so that this is satisfied, again with equality. That's a standard assumption. So if you have the same profit, if you tell the truth, then if you lie, if you cheat, we assume that you tell the truth then. So we just assume that you set that equal and solve for pH, and therefore pH has to be equal or even smaller than a C plus this here. And again, of course, it's clear. Here you have the lambda in a denominator. The smaller the share, we just have to check here. Yeah, suppose lambda goes to 1, then this could become arbitrarily high, okay? Because the denominator goes to 0. And therefore, it's no longer a constraint if lambda gets high enough. If it gets smaller, and for instance, if it's lambda is equal to 0, no informed consumer, you see immediately, then the C would just cancel out, and the ICC, the incentive compatibility constraint of the low type, would only hold if RL is equal to or if the price of the high type is also equal to RL. And so what you see here, and then it's just an increasing function as of lambda. Okay, pH increases as the share decreases because here the denominator decreases and therefore the whole expression increases. Okay, and so you see it's a relation between the two, and what we have to check is whether, given this incentive compatibility constraint, whether it's optimal to do that. That again depends on what we expect in terms of the beliefs of the consumers. If they believe that if the price if this price is not such that the incentive compatibility constraint holds, if they believe in this case that's a low type firm anyway, then probably it's always optimal to charge or to satisfy this incentive compatibility constraint. Okay, so what we have learned here, and that's the lesson Martin and Paul wrote down, if some consumers know the product quality, the high quality firm can use its price to signal quality to the remaining share of the uninformed consumers. Okay, and it always depends on how high this share is. And as the share of informed consumers increases, the price of the high quality firm reaches the corresponding full information price. Buffer critical size of informed consumer signaling is visible with full information prices. And of course here, what I have to tell you, of course, it's not always optimal to charge the price or this price, because that really depends on the lambda, on this share of informed consumers. I think I should check this once again by looking into the textbook. I think they just derive it in a way that they're always indifferent as well. Yeah, so they have a footnote that they leave it to the interested leader to apply equilibrium section arguments, equilibrium selection arguments, because in some situation the firm would prefer to be in the pooling equilibrium. Okay, but the point is here, apart from this minor deviations, and we see how we can solve the problem and how a certain share of informed consumers can help you to really even use prices as a signal. And hopefully you got this. Yeah, the final part I want to present to you is how prices can be used as signals if there are cost differences. Again, single period, and we have a cost difference between a high and a low quality. The consumers have variable demand, and we have low quality at marginal cost CL, high quality at marginal cost CH. Demand is independent of true quality, since consumers purchase only once and no consumer has any private information on the product's quality, so they don't know that. Okay, if there is no further information, they just assume that then it's a low quality, I guess. So the point is, and the result which we want to show, actually only sketch here, that the price can be used as a signal. And the idea is here again the incentive compatibility constraints matter. And the idea, I didn't manage to come up with nice parameter values here in this model, and probably for next year I'm going to try to come up with a nice equilibrium. The idea here is the following: if, of course, that would be a standard case if, first of all, what we always have is that RH, hopefully that's somewhere written on the previous, not even, but what is clear is that that consumers are willing to pay more for the high quality than for the low quality. And at the same time, of course, CH should be higher than CL. Now the point here is, of course, given this price, it's always optimal, given you charge a price equal to the willingness to pay here, it's always, or actually, it's wrong, because here, that's what I should have told, we have the assumption here of variable demand. Paul and Martin use a kind of special demand function here, which is something like Q is derived from some hoteling model, and I didn't want to use this. It's just 1/2 just times 1 plus this S would be the quality level. Okay, this would be the quality level, and this E means the expected quality level minus the price. So here you see you have elastic demand, and that's the point is here in the notes I wrote, for instance, here the quality level will be 0 if you the quality level will be 0 if it's a low quality, and 1 if it's a high quality. Then actually you simply have some linear demand functions, and the idea here is, of course, for this linear demand function, the monopoly price is always 1/2 of the vertical, 1/2 of the vertical intercept plus here A plus C over 2. I don't need to go into detail, so I should erase that anyway again, because the more relevant part is the other. So the idea is what happens here is if you charge a very high price, and very high price here means a price much above the monopoly price, there is some part in which the firm, suppose you charge here, so you have a maximum willingness of 2 here, if you have a high type, okay, as high quality would be 1, so Q would be just 1/2 times 2 minus P. So the maximum willingness would be 2. Suppose you as a high quality firm charge a price of 1.8. Okay, that does mean that there is only very little demand, and then of course it would be better for the low type really to say, actually I'm a low type and I sell you this at the monopoly price of say 1/2, and then I get much higher demand. Okay, so the point is here, starting from some price for the high product here, the low guy here no longer wants to claim to be a high product and set the same price, because its profit from the low quality is higher, from truthfully telling from the low quality, it says the low quality is higher. Okay, and of course there's also a very low price in which you don't want to claim to be a high quality, because you hardly make any profits. And what you have to find out is, given that you have to charge a price which is much above the monopoly price, you have to check also the other incentive compatibility constraint of the high type. And what you can see is that there's an overlap, and you can really calculate the price at which or the price might exist. Okay, you never know, or certainly not for all parameter values there will such an overlap exist. Okay, but certainly there are conditions under which such an overlap exists. And next year probably I will come up with a nice example. Given that I switched only our program last week, I was not able to do that in the meantime. But anyway, so you probably, I should give you that as an exercise. Okay, so the idea hopefully should be clear. You charge too high a price in a sense as a high quality, so that the low quality rather wants to truthfully reveal that it's low quality and earn the monopoly profit as a low quality. Okay, and the less interesting case is if the price of the high quality is lower than that of the low quality. Again, low price exists in this situation, so that the firm doesn't want to get to charge as low a price as you have here, and you also can signal its type by sufficiently low price. Okay, in an environment with asymmetric information about a firm's quality, so that's how we can sum that up. If marginal costs depend on quality, a firm can signal its product quality with price. Signaling is possibly costly, and a firm sets a price that is different from its full information price, so it's much above the monopoly price, for instance. Okay, hopefully you got this idea. I will work on that and hopefully be able to not only give you these sketches, but perhaps nicer or specific examples for specific numerical values. I think that's about it. I don't want to move on here because this is again this repeat business where we, and I briefly discussed that, jointly use the price and advertising as a signal. I don't want to do that here. What you hopefully saw is that there is a lot to do for applied microeconomists, in particular in terms of the policy conclusions we saw in terms of advertising, that it might be informative, that it's a good thing, that we might even do welfare not really a favor if we prohibit only partial informative advertising and so on. So there is a question of whether policy should oblige firms to reveal their quality truthful, whether it should enforce minimum quality standards and so on, or public quality checks. These are all quite interesting and relevant questions. Their answer, at least, is in terms of further, at least partially, is in terms of further theoretical models. And I cannot provide them here. You have to wait for a PhD course in IO here for that topics. I give regularly such a course, and perhaps you join me there if you intend to pursue a doctorate. The point, however, is if you are further interested in further topics here of applied microeconomics, if you're further interested in topics of adverse selection and moral hazard, of principal agent problems and information economics problems more generally, perhaps you might be interested to take my course in economics of regulation. If you're more interested in terms of dynamic competition, research and development, hopefully you take my course Economics of Innovation. I thank you for taking this course and being with me the whole semester. It gets dark, so I have to finish with my lecture now. Anyway, I wish you good luck in the final exam. Thank you once again, and be available in WebEx some more time, and goodbye. Thanks.